In section 4.3, there are problems where they ask you to use the remainder theorem to find the remainder for each division, and then state whether the binomial is a factor of the polynomial. So what they want you to do first of all is to set up a division problem, and we're going to use synthetic division since the polynomial we're dividing by has x to the first power as the largest power of x. So here's how to set up synthetic division. You first take the opposite of the constant, so in this case positive 2, and you put that inside of this little half box thing. Then you draw a nice long line, leaving a line of space between that half box and this line that you're drawing. And then across the top where you have that half box, put the coefficients, or in other words the numbers in front of the powers of x in the polynomial that you're dividing into. Don't forget, if there's a missing power of x, you need to put a 0 in there as sort of a placeholder. So the number in front of x to the third is 1. Then we see that there aren't any x squareds, so we have to put 0 in as a placeholder for the x squared term. Then we have a number in front of x being -1, and finally our constant is 6. Then what I usually do is I create kind of a half box here underneath the constant and also underneath that long line that we drew. Alright, synthetic division, first step, you bring down your first coefficient below the line, and then from here, every time you have a number below the line, you multiply it with the number that is in this upper left half box. So 1 times 2 is 2, and that goes above the line, and then two numbers in the same column above the line, we just add them together. So 0 plus 2 is 2. Well, now I've got something below, so I multiply. So it's a pattern of multiply, add, multiply, add, multiply, add. So multiply 2 times 2, we get 4. -1 plus 4 is 3. 3 times 2 is 6. And finally 6 plus 6 is 12. Okay, so that's the division part of it. And now what they're wanting us to do is find the remainder for each division. Well, the remainder is this part in the lower half box. So the remainder is 12. And since the remainder is not 0, we can say that the binomial that we were dividing by is not a factor. In addition, the remainder theorem also states that since the remainder is 12, that this number that we put in the half box, if we were to call, let's say, the original polynomial, we'll call that f of x, x to the third minus x plus 6. Doing this division and finding the remainder is equivalent to finding a function value. In other words, if you plug the number 2 into the function, since that's the number that's in this half box, that will give you 12, since that's the remainder that we found with synthetic division. And you can check to make sure that that works by plugging 2 in and doing the calculations, but that will work every time using the remainder theorem.